Calculus students, to the Unit 2123 review video. Hopefully you find it helpful. You can fast forward to the parts you need to watch. And be sure to post a comment if you like it on our Google Classroom page. Okay, first of all, not too big of a deal here. We're basically finding the y value when x is 1. So in the function, we are literally going to replace x with 1. So we're going to have 1 squared plus 1. And then we just work it out. And we have the square root of 1 plus 1, which is the square root of 2. So basically all we're doing is we are plugging in x and finding out what y is. The y value is the answer. No need to go to ordered pair form there. Now this one, it looks like it didn't show up real well on my PDF, but I know that's supposed to be f of the opposite of x. So what we're going to do in this situation is we are going to plug in the opposite of x and see how things change. Well, there's some simplifying that needs to be done sometimes, but with this radical we're not going to have much to do. So basically we have the square root, and like we've been saying in class, if you put in a 5 and square it, you'll get 25. If you put in a negative 5 and square it, you'll still get 25. So nothing changes when there's an even power like that. So I'm not even going to show it plugged in. I'm just going to say that that's x squared. But on the back end, if we replace this x with a negative x, or the opposite of x, we will have minus x right there. And that's as far as we can go, really. We're just showing the function evaluated at the opposite of x. Now that's different as the function evaluated, or when we take the opposite of the function evaluated at x. So that's simply, and this one is a little bit, I don't know, simpler than the other ones like the fractions we've had. Look back at your practice on those, but you just need to take the opposite of whatever the function is. Well, what we'd want to do is distribute the negative through, but since we have this radical here, there's not much we can do to this problem, but just kind of leave it right there. But the idea is to take negative 1 times that. And remember, on those ones in your practice, if you have a fraction and you are going to take negative 1 times that, you either go to the top or go to the bottom. Don't go to both, because then you really didn't do anything. All right, this one here. So a little bit of algebra simplification here. This is going to be equivalent to the square root, and that x literally turns into x plus h. So we replace it. So we have x plus h quantity squared, and then plus the x at the end also turns into x plus h. Well, what we have to do now is we have to expand this binomial. Some of you will rewrite and FOIL that, that's fine, but you're going to get x squared plus outside and inside will give you 2xh. Last will give you h squared, and then you still have to tack on the plus x and the plus h. And as you can see here, there are no like terms there, so there's really no further we need you to go with that one. Every one of these is different. Make sure you're practicing a lot of them. This radical is different than a fraction, which is different than a polynomial function. Just kind of look at the differences. Okay, speaking of which, we have a fraction now, all right, to look at, rational one. And is the point 1 3/5 on the graph? Well, all that means is if you put in a 1, do you get 3/5? So that's what I'm going to do. I'm going to say, okay, 1 squared is 1 on top plus 2. On the bottom, we would have 1 plus 4. So this is coming out to, there we go, 3/5. So to answer the question, yes, because when you put in an x of 1, you get out a y of 3/5. A little different now. This one is saying that the function's value is 1/2. Well, that's not x, that's over here. So now look how this works. I have 1 divided by 2 is actually equivalent to x squared plus 2 over x plus 4. Okay? So now we have a y value, find x. Well, everyone's a little tricky here. I think one of the best things you guys probably remember is cross multiplication here. So if I take 1 times x plus 4, I would get just x plus 4. And then on the other one, you just got to remember to distribute it through. So that would be distribute the 2x squared plus distribute the 2, 4. And then one of the biggest things you got to get this year is that if you have x squared and another x term, we want to get one side equal to 0. Well, I'm going to take care of these 4's already, because if you subtract 4 from both sides, it's gone. I'm going to make this side 0, and I'm going to do that by subtracting x from both sides. Okay, so this is where we're at. Well, here we go. Hopefully our algebra instincts are strong. What we want to do at that point is solve. So that's GCF of x. And then on the inside binomial, you have 2x minus 1. Because when you distribute, that's what you get. Straight up algebra. Now we got our split for ourselves. So this one, you're going to have x equals 0. Or you're going to get x, well, I'll write it out, 2x minus 1 equals 0. But then when you solve that, add 1 divided by 2, you'll get x of 1/2. So they're asking for the x values. When y is 1/2, there's actually 2 x values here, where it comes out to y being 1/2. Okay? So here we go, on to C. List the x-intercepts. We need to know, wow, that was kind of loud, sorry. We need to know the definition of x-intercepts. Please know those. X value when y is 0. X value when y is 0. So the left side just becomes 0. We have x squared plus 2 over x plus 4. All right, well now we want to solve this. So I'm going to multiply by x plus 4 to both sides. That cancels there. Multiply to x plus 4 to this side. 0. So I get 0 equals x squared plus 2. Subtract 2 from both sides, and here we go. Negative 2 equals x squared. Well, this is kind of silly, guys. Look at this. In the real number system, can I square anything and get a negative? No. So since it doesn't work out and I can't find x-intercepts, that just means that, what? There aren't any, so there's none in this situation. And that is possible. I mean, this isn't a parabola, but just think of a parabola. Like, could a parabola go like that and not cross the x-axis? So in this case, there's no x-intercepts here. Okay, list the, excuse me, list the y-intercept if there is one of the function. All right, so the y-intercept is the gotta know that. Y value when x is 0. So that's actually pretty straightforward. Put a 0 in for x and see what you come up with. Well, if I do that, I'm going to get 0 squared plus 2 on top. I'm going to get 0 plus 4 on the bottom. So that's coming out to 2 over 4 or 1/2. So our y-intercept is 0 and then 1/2. Okay, that's the idea on that one. All right, so number 3 here. What we have is, we have x's, we got a function like a y value there, we got a b, but we have a lot of information right here. So I'll switch colors here in blue so we can see this. That says put in an x of 2 and you will get a function value of 1/2. So I'm going to say let's make the function's value 1/2 on the left side. But if I do that, I've just established the x value as 2. So I'm going to replace the x's with 2. And then the b, that's going to be the only variable left, which is great because that's the goal of this problem, is to find b. Okay, so to simplify this, I have 1/2 equals 4 minus b divided by 6 plus 4 is 10. So again, however, there's multiple ways to solve this, but if you guys like the cross multiplication, just remember to distribute this 2. So you'll get 8, 2 times 4 is 8, minus 2b equals 10. Subtract the 8 from both sides, and we're back to solving a simple equation. So b would be -1. Obviously, you can plug everything in, check it out, make sure that that rings true with you. Okay, in this video, I'm going to go to one more concept before I cut it short, before it gets too long. We're going to talk about domain here. All right, we've been, typically kids have a little trouble with these domain ones at the beginning. Hopefully, you're battling through that and trying to get these correct. So here we go. Fraction, radical, and polynomial function, which we call, but it has no breaks. Like, I'm going to the easy one first. I'm going to go to B right now. There's no issue here. If I was to go make a table of values, you can always make a table of values with these. Put in an x, get out a y. There's no value of x I can pick that won't give me a y value. Any number you think of, just put it in there and you will get a y value. I'm not saying it'll be a pretty answer, but it will be a real number. So when that's the case, that's literally the way you would want to say all real numbers for your domain, like -infinity to infinity. Everything will work. Everything fits. The domain is the set of everything that works for the x value. So now let's jump up here. This is different because we have a denominator. That denominator, don't look at the x, the whole denominator cannot be 0. We just can't have it. So think about this. If I make a chart, and you don't have to do this every time, but I'm just teaching it again, is that if you put in, let's say, a 4. If I put in a 4 here, that numerator becomes 4 minus 4, which is 0, over 4 squared. 16 minus 25, which is negative 9. It becomes 0. 0 is a number. That's totally fine. 4 is in our domain. If you put in 6, 7, lots of numbers, but you can't put in 5. Because 5 squared is 25, that will make 0 in the denominator. If you put in 5, it's undefined. If you put in negative 5, that's undefined because you're still going to square it. So basically, if you didn't know that by looking at it, you're going like this. You're saying, I know that denominator cannot equal 0. And then you just go through and you solve. The denominator cannot be 25 when you add 25. Now you do your square root. X is equal to plus or minus 5. And actually, it's the fact that x cannot equal plus or minus 5. So the actual domain is everything else. So we need to say to ourselves, okay, so here it goes. This is a little tricky for some, but everything works in the negative direction, all the way to negative infinity. All the way up to, well, negative 5 does not work. But everything between negative 5, okay, so everything to here, negative infinity to negative 5. And then everything from negative 5 to 5 works. Everything in between there works. Don't miss that crucial part of it. And then everything from 5 to infinity works. These parentheses tell us that there are only 2 values that do not work. And that would be negative 5 and 5. Okay, so a lot of people miss this middle part. But if you do that, you're saying all of the values from negative 5 to 5 don't work. And that's not true. They are in our domain. Okay, now down here, I gotta switch colors, seeing too much red here. So in the radical now, what do we need to know? Well, that whole expression inside, anytime it's a radical, that expression has to be greater than or equal to 0. The square root of 0 is totally fine, and positive numbers, when we take the square root, are fine, but negatives are not. So that's what that says. As simple as that. So I'm gonna go ahead and solve this now. 2x is greater than or equal to 6. And then x is greater than or equal to 3. That's it. So basically, when we go to interval notation, we notate it with a bracket because 3 is okay. Think about it. Put a 3 in. You get 6 minus 6, you get 0. Square root of 0 is fine. But if you put any smaller number than 3 in, you're going to end up getting a negative in the radical, and that does not work. Okay, I'm going to cut this video, and we'll start up another one so they're not too long.